In this instruction video I will explain you how to create a system architecture for your collaborative design project. First, we define systems architecture and how it is used in the collaborative design project. Then I will explain how you can draw a diagram that shows the connections between computer tools and how the information flows through the system. And finally, some examples are given. First, a few words about the term system. In systems engineering, the system, in the context of architecture engineering and construction, is often interpreted as the room, the building, or the neighborhood that accommodates our human activities. In information systems, a system is usually interpreted as a software program or computer tool that can process data. For systems architecture in this course, we use the second definition, namely the interconnection between different computer tools. In literature, systems architecture is defined as a complex system that is partitioned into relatively independent modules. The independent modules in our project are implemented by computer tools for the creation of the design. In this course you are requested to present a system architecture diagram of a system. From the assignment I copied the description of a system architecture in the collaborative design project. A system should be created that allows you to monitor the project progress and create a log that registers compliance or deviations with the project management plan. The log must enable anyone to completely trace every product or process change. The monitoring system is developed using existing SE tools, BIM tools, other data management tools, or a combination of these. In your report you are requested to present a system architecture diagram of this monitoring system. The first symbol introduced on this slide for representation of a process and a system architecture is the rectangle. A process in the collaborative design monitoring system is implemented by a SE, BIM, design, and GIS tools. On the slide you can read some examples of computer tools that you can use for this purpose. In the rectangle you write the name of the computer tool that you have selected. The second symbol is the skewed rectangle for representation of data that is imported or exported from a process. Data can take different forms, such as a table, a document, a map, a 3D model, or raster data. On the slide you can read examples of well-known file formats that can contain these data. These file formats are available as import or export functions in the computer tools that you have selected for this project. Every computer tools only supports a limited number of import and export formats, dependent on the characteristics of the computer tool. Some of these formats are open formats, while others are software vendor proprietary formats. In the skewed rectangle you write the name of the file format that is exchanged. The third symbol is a cylinder, used to represent a database. Often data is used only temporarily for data exchange between computer tools, but if you want to store information for useful reuse later on in the process you need a database. Databases can be implemented by simple log files, but also be complex database systems. On the slide you can read examples of databases that you could use in the collaborative design project. Since monitoring is the main purpose of the system, databases play an important role. Now we're ready to draw the first simple system architecture. In this example, process 1 and 2 generate output that is used as input for process 3. Remember that processes in this monitoring system are implemented by computer tools. Data is flowing through the lines that connect the processes. In practice, data is usually exported from computer programs in a specific file format. Therefore, in this example, the data that is exchanged between the processes is explicitly inserted into the system architecture. The data files that are exported often have names that reflect the content of the file, such as list of requirements, architectural design, installations design, etc. The files are structured according to a specific file format such as RVT, PDF, SHOP, IFC, etc. In the system architecture diagram, the process element names are filled in by the computer tool names, and the data element names are filled in by the file content plus the file format between brackets. Avoid using file content names that include an indication of a design stage such as preliminary design. The system architecture should be time independent. The data file exchange between the processes is only temporary and not archived. In this example, a database is added for permanent data storage and retrieval by another process at later stage. Similar to the data element, a database element name is filled in by the database content plus the format used for data storage between brackets. Sometimes data output is reused as data input in previous processes. In that case, a feedback loop is created. Since collaborated design processes are cyclic in nature, feedback loops are often needed to implement these design cycles. Finally, a simple example of a system architecture for the collaborative design project. In this example, the wishes expressed by the client are used as input by the architect to create an architectural design in Revit. When the architect is ready, he exports the model in IFC format and uploads this to the model database. The structural engineer uses Tekla for the structural design. He downloads the architectural design from the database and imports this file into Tekla. When he is ready, he exports only the structural design in IFC format. The systems engineer in the project team uses Solibri for clash detection. He downloads the architectural model from the database and he imports this model in Solibri. Additionally, the structural model from the structural engineer is imported. Now he is ready to perform a clash detection in Solibri. Obviously, in the collaborated design project the system architecture is more complex. Then a few concluding remarks about the assignment in the collaborative design project. Of course, you should test your system architecture if there is any data loss. The tools that you want to use should be accessible to you. Beware of limitations for educational licenses or trial versions. Objects, such as doors, should keep unique identifiers throughout the whole design process, otherwise it is impossible to trace what happened afterwards. Finally, you do not only need design and engineering tools, but also data management tools to trace design changes. So, to summarize, you should create a systems architecture diagram consisting of ICT tools used during the collaborative design project, that also supports data monitoring during the project. This includes making sure that the proposed workflow works. If you want to learn more about systems architecture design and about systems engineering in general, then download the book presented on this slide from the University Library. In this book you can find many useful tips.